Now you can see the changes here. Now the width is 3 mm. This is your microstrip line. Microstrip line is nothing but it's similar to the transmission line, which is used to carry the electromagnetic signal from the coax cable to the patch. So let's name this one for identification. This is my patch. And this rectangle, when you are clicking this, the particular shape is getting selected. So from that you can identify it. This rectangle is of microstrip line, named as microstrip line. So now you can see the difference here. The microstrip line and the patch is connected here, but you have some disconnect between this. So this can be directly connected, and uh, you, you can select microstrip line and use control key to select to hold the selection, right? Use control key to hold the selection. You select your microstrip patch also. So now you can see the difference. Both the structures has been selected. When both the structures are getting selected, these things will be highlighted. Unite, split, subtract, intersect, imprint, all this will be called as Boolean operations. These are getting highlighted. Or in the modeler menu, you can go to the Boolean tab, and in Boolean you have unite. So both anyone, either using the shortcut you can use, or here you can use give unite. So now look at this. The line between these two structures is vanished. So you can see the smooth transition from the microstrip line to patch. If any of your dimensions are changing, or if it is not in the same plane, then you cannot see this one. Right, so you will be having a mismatch till, so there will be a line appearing in this structure after giving the unite also. If both are in the same plane, that is in the same Z plane, then only it will be united. The same thing for subtraction, another thing also, both has to be on the same plane. Right, so now we have completed the structure. So I have drawn the patch antenna, I have connected the transmission line also, and the basic structures I have completed. The ground has been given, and now I need to, this is the first step in the any antenna design or microstrip components, sorry, microwave component design. First you draw the structure of a particular component, or draw the structure of the antenna. Once you have completed the structure, you have to assign all the boundaries and the materials. Right, and now as I told, substrate I have to take it as a commercially available substrate, so I'll be going for vacuum. To do that, to assign the material, uh, left right click on this, double click on the vacuum, so you will be getting a material size, or right click on this and go to the assign material. Wait. So right click on the substrate, go to the assign material. Right click on the substrate and go to the assign material. In the assign material, the library will be opening here. This is the system library. So the system library will open here, and you can see the number of materials here. These are all the available materials. This can be used for either patch or for your substrate for or any other purposes. So now I'm going to use the FR4 substrate. So this FR4 substrate is commercially available substrate. Its cost is also less. So this is your FR4 epoxy material. Okay. So you can also do the search by name or by property, because normally we will be selecting the epsilon or the relative permittivity of the material is similar to or equivalent to 1. We will be selecting the substrate. If for epoxy is having the epsilon or relative permittivity as a 4.4, you can see it here 4.4. So normally we will select like that. So if you go the substrates which is having epsilon r is equal to 1 in dielectric, it is very rare. Right, mostly the conductors will have epsilon r is equal to 1, and dielectrics will be having higher relative permittivity. So we have to use the dielectric for substrate. All these things you will be studying later in your antenna theory. So let us start it here as assign the material as FR4 epoxy, give OK. Okay. So other things, the ground and the line, all these things are connected as both are united, and this is shown as unassigned. So this material you cannot assign because it is not the 3-dimension structures, it is the 2-dimension structures. So if you want to do it as the material assignment, you have to make some thickness. You have to increase the thickness of the sheets, then you can go for the material. Otherwise, you can assume it as a boundary, right? We can assign boundary for this. So let us select one by one. The ground I have selected now. The ground is also a conducting material. So I'll go for the assign boundary. It's a conducting material, right? So I'll be assigning finite conductivity. Either I can go for the finite conductivity or perfect E structure. Perfect E structure is also assigning the conducting material to the boundary. Right, so either I can go for finite conductivity or perfect E. Let us go for the finite conductivity. Finite conductivity. See here the finite conductivity, the parameters of the conductivity is given here as 58,000 Siemens. So this is 58 mega Siemens, 58 into 10 to the power 6 Siemens. Which conducting material is having this much of 58 into 10 to the power 6 Siemens? It is copper. So you are assigning a conducting material for ground using the finite conductivity assignment, right? So now look at this. Under sheets you have finite conductivity. Under finite conductivity your ground is assigned. So another thing is unassigned, which is your patch. The microstrip line and the patch is getting united. This is uh, unassigned. Now this can also be assigned as finite conducting material because we need only a conductor. Assign boundary, go to the finite conductivity, check the conductivity as 58 the mega Siemens. That is nothing but your copper. Give it as OK. So we have completed the what it is boundary assignment. Now look at this HFSS design. Already I have told in the initial video. First you have to complete the 3D components. 3D components in the model. Here we are not using any circuit elements. If you require, you can also complete this. This is about the structuring of your antenna or microwave component, whichever you want to do the simulation. Next, we have completed the boundaries. So we have completed the boundaries. We have assigned the materials also. And the next thing is we have to assign the excitation. Like how we are giving the voltage source, current source in your electronics lab. Similar to that, we have to give the excitations. So excitations where you have to excite through the line. Through this line has to be connected to the excitation or the source. So I'll rotate this line. Sorry, I will rotate this texture just to see this width because I am going to connect it at this point, and along this thickness of the material I am going to connect it. Right. So I rotated it just to see this space, and now I'll be zooming it, zooming this place little wider. Right. So here I have to assign the material. Right. For this, I'll be drawing a small rectangle. Right. Small rectangle sheet. Right. Which covers the entire length and width. Sorry. So what I am trying to do it now is I have to draw the rectangle in this plane, it is in the XZ plane. Now it is in XY plane, right? All the things you have drawn it as a horizontal length as your Y and vertical length as X. So in the XY plane. Now I'll be changing this as XZ plane. Right? In the XZ planes, I'm trying to draw the rectangle, right? So now I'll draw this.